Hey, welcome back, everyone. I'd like to introduce Barry Price, our presenter for tonight on his spiral attachment. Barry has wowed us with his jigs in the past, so I'm looking forward to seeing what he has for us tonight.
Before I say anything about the spiral jig, I want to thank Matt here for 2 years of great service. He stepped up when we needed a president. He was a pretty new member. What, do you have 2 years under your belt then?
If that, I think.
He was hard to talk into it, but COVID was underway about 8 months, I guess, and we had Zoom established, but Matt stepped up and really did a great job for the last 2 years. And I'm going to have, well, quite literally, big shoes to fill. Well, thank you, Matt. Okay, spiraling jigs. When I was about 22 years old and living in my first house, there was a Sears thing called I wrote it down here, a router crafter. I don't know if anybody out in Zoom has seen these or used them or whatever. I never bought one, but I had a friend that had one. And I had no experience in woodworking then except for furniture making. And he was, I'm not sure to what end, but he was knocking out a lot of, I guess, 2.5-inch squares with spirals. They were too short to be a baluster and too long to be a club. So I'm not sure what they were for, but he was making a bunch of them. And I was impressed by how the thing converted linear or got rotary motion out of linear travel. Okay, that just kind of went on the shelf for years then. And then at the beginning of COVID, like maybe March or April of 2020, I, like everybody, went stir crazy, and I got a renewed interest in jig making. I made several other jigs, and I just zeroed in on this. There's a product called a flute master. And I often call it a spiral master by mistake. It's a very, I think it's the only commercial spiral making device that's out there. I think it's made in Texas. It's all blue plastic, seemingly about, well, more parts than I have here. And it's driven by a bead chain, very large, fairly strong bead chain. And it is clever, but it leaves something, I guess everything leaves something to be desired. That, to me, left a lot to be desired, mainly in that your cutting tool was not attached to the bed. You simply had to make sure you were mindful on holding it down while you were cutting. And when you're cutting spirals and such, your mind can wander, and you can easily let go of your pressure down here. And anybody who's ever used a router in wood knows that a little bit of inattention and it can quickly do chattering. And if you already have 8 or 9 hours into your piece, it destroys it right then. So I like the fact that it's held down. So I made my first version, and if you Google Lathe spiral jigs, one of the YouTube videos that comes up is the video that John Kelsey made during COVID for, I think, one of our Woodturners meetings. He came over to my house, shot a bunch of video, edited it, and it was admittedly a complicated rig. It had a threaded rod drive shaft and an elaborate cluster of gears and sprockets here and multiple belts and changing helix angle was a nightmare. I mean, just in time. It wasn't hard to do. It was just time consuming. You couldn't change your mind at the last minute and accomplish it. And I guess about a year after I made that, Thomas Gerdo Davis, who now is a member of our club as well as the Keystone Club invited me to present my spiraling jig. And I was right in the middle of transitioning to a non-drive shaft made one. And it was kind of a catastrophe because I couldn't adapt. They were turning, their club lathe was an American Beauty, I think. Is that right?
Yeah.
And it's got like a, what is it, a 20-inch? It's a very high spindle. And I was at the time turning on a 12-inch jet. And so to accommodate the different bed width and thickness and height and everything, I just went ahead and made a little, you know what 80-20 aluminum is, structural aluminum. I made a little non-motorized lathe that I could demonstrate on. And it had all the functionality, but it was not terribly stable. And anyhow, the demo didn't go well. Hopefully tonight goes better, but no guarantees.
Barry, the demo went great. We were all amazed at your ingenuity to just make a lathe mock-up to be able to do this demo. That was amazing.
Oh,
Yeah.
well, thank you. I'm pretty self-critical on
No,
everything.
it went great. Everybody really enjoyed that.
Thank you. Anyhow, I made a second version that you saw the mock-up of on that thing. And now I have a third version about 5 months ago. No, I guess it was only about 4 months ago. Dave Shell, who I think is on our attendees tonight, did a presentation on what he called basic spirals. And he had objects here that included a bowl. And he happened to mention, somebody said, did you think about using a spiraling jig like Barry's jig? And he said, no, it takes too much time to set it up. And by that time, he could already have the bowl made or something like that. Then he also said something that was important. He said, I have 32 spiral cut bowls on backlog. He makes a reasonable living on selling his work. And I was thinking, well, geez, if I got 32 bowls on backlog and I'm still taking orders, I have time to consider a jig of some kind to cut those slots, even if only just to draw the pattern. If you're making them all the same, you can really economize on it. So let me start with this. My introduction to the whole technique here was I happened to see a YouTube video on how to mend a 3D printer belt. I had never given any thought to what a 3D printer belt was. Here's 15 feet of it right here. All the stuff you can buy on Amazon, and it all seems to be priced about the same. This is like, I think like $9 for this. And you can make your drive system out of, you can make it 3 times over with this. And if the camera can, one of the cameras can see on the bed here.
Yeah, switch to the, you got it.
Okay. What you're looking at here is this is a 60-tooth pulley, as they call it, or a sprocket. They are machined. I don't know how they can do them. I mean, I don't know how they can do them this cheap. You typically are buying a 2-pack for like $14. So anyhow, there's a 60-tooth, a 40-tooth, and a 20-tooth. And now recently, and I just saw it on Amazon, I ordered it, but I don't have it yet, but an 80-tooth sprocket. And the teeth on this sprocket engage with, this is a piece of one of these belts that I cut to the required length and mended it using my own method of mending. And it may break during the demo. I brought CA glue in case it does. Anyhow, it fits perfectly in these teeth. So there's no slippage. You have tremendous repeatability, spacing control. And most importantly, you can twist it in its drive pattern. So you can go from an XY pattern to a YZ pattern or a ZX pattern, you know, the axis of the travel. You can turn it 90 degrees. You could possibly even turn it 180, but what's the point? But you'll see how it comes together as I do this. All right, let's start to assemble it here. First of all, unlike my other ones, this could be mounted on the headstock or the tailstock. It doesn't matter. In fact, this is mine. This is the shop's here. If you have a Powermatic or a Jet that's been sold in about the past 8 years, it comes with this kind of free center, live center. And what we do is expose it has a 3/4 inch. They have a 3/4 inch thread pattern under the nose cone. And that becomes important for what we're going to do here. Don't want to have it come loose on me. So a thing that I made, and a jig that I showed about 2 years ago was it was my version. It wasn't original in any sense, but it was my version of a threading jig. And I used it to turn these 1 1/4 threads on the outside of a piece of Delrin, 1.5 Delrin, courtesy of Matt back here, who had a bunch of 1 or 3 inch long pieces of Delrin. It turns beautifully. And on the inside, I put a 3/4 inch thread. Not using a threading device. This was using a tap. I do have 3/4 inch tap. I don't have 1 1/4 tap. I don't have a die. So we put that on. And this is a little shop made. I actually took a commercial template and drilled holes. This is a every 10-degree kind of ring. You can make them any pattern you want, really fine, really coarse. So I have them marked here for every 30 degrees. And it sits on the shoulder there. And this is the regular stronghold chuck that had been modified by me in the sense that I put double stick tape around the hub back here and put 100 grit wet or dry sandpaper on it to provide enough friction so that the belts won't slip, because they're meant to really ride in a toothed situation. Now that, I ought to also say that before you get going very far down the road, disable so that you don't accidentally, when you're meaning to turn on your cutter, you don't accidentally turn the lathe on, or you could rip everything apart. I have the headstock locked.
Yeah, the lathe is not plugged in either, I don't think.
I'm sorry?
I don't think the lathe is plugged in.
Oh, that's also a good safety aid. Don't give it away, John. Okay, so this first component, which I'm calling the headstock component, it could also go down here, and then it's it just seems to work better for me out of familiarity, and I'll say being left-handed, I'm just used to having it on the left. And it sits down in the bedways here. I had put this adjustable, I put an adjustable bolt on the back so that it's adjusted so it comes up just in light contact with this, so you can pin this at any position, and you have no if there was much of a gap there, you could bend the pin kind of, and it induces some chatter, allows some chatter to happen. This is the tooth pattern on these belts is it's a 2 millimeter spacing between teeth, and they are 6 millimeters wide. And if you Google or if you Amazon or anything, GT2 timing belt, everything about this is GT2 pattern. I'm not sure if what that GT stands for. But anyhow, we slide this over here and put it on the aforementioned grit. Now, it doesn't really matter which sprocket I put on, but I'm going to put on the 60-tooth one. And don't tell me I didn't bring the tool for taking. Not that tool. No. Here it is. Thank you. Well, anyhow, these sprockets have two little set screws in them. And this thing features this vertically sliding piece here. You slip your belt around there, put some tension on it. So now you can drive it from down here. Oops. I better secure this. I failed to do that. So that is it. That's the final drive. We have to put another sprocket on here so that when we put the rest of the components on, you can drive it and tension it separately from this. These pulleys are also Amazon. Some of the deals they offer are a mix of pulleys and sprockets and belts that you buy for all for one price. And I still need one more pulley. And these all have bearings on them in them. And the shaft in this securing thing right here is a double bearing. They have a pair of bearings spaced about 1.25 inches apart, so it provides real stiffness and easy rotation. The next part to go on is the carriage. And this is just basically modified. I shouldn't say basically. This is modified from what I use at home. Like I say, my jet has a different height, different bed gap, bed thickness, and so I modified this thing here. And then masking tape is key to my solutions quite often. And I had it up here, and it was It was too tight thickness wise and too sloppy width wise. So I added tape to it to the point where when it was tightened down and it had no free play, it also didn't have so much friction that you couldn't slide the carriage. Okay, so there we're down and it slides freely. And the final component to put on is the belt tensioning bracket. And I want to give a shout out here to Randy out there. When I showed my last version, it was you had to use a screw and a homemade clamps to secure the belt to the carriage. And Randy was out in Zoom land and said, why don't you use toggle fasteners? And so if you're still out there, Randy, thank you. That's what I did on this version and they work great. So it seems like a mechanical nightmare here to do all this routing. And here's where you twist the belt 1/2 turn. So you go from this axis to this axis. And there we have it. So if you had,
There we have it. It's right, got it.
Just like that.
there, some of us have it. Anyhow, what I will call forward motion, just because it's closest to me, you clamp this toggle and it pinches on the belt. So when I move right to left, it's going clockwise. If I secure the rear toggle without having to come around and use the screw, when I move it from right to left, it goes counterclockwise. And that allows you to do diamond patterns, or as I'm going to try to do tonight, a pineapple. So there is that. And the final monster piece, I think I said that was final. I lied. You're going nowhere without having a riser for your cutter. And this brings your cutter, whatever kind of cutter you're using, it brings it so that the nose of the cutter is right on the height of this. I think this is like a 10.42 or something height. And it's got multiple positions. You can put it for if you're doing a bowl, or bring it way in if you're doing a small diameter thing. I just put it here in the middle. And it's articulated in the sense that I can rotate it here and also rotate it up here to make sure that I have the cutter at the angle I want with respect to the wood, and yet able to reach the two ends of the, or the two stop points if I'm doing limited length spirals. Anyhow, just to start off, it's not really lockdown, it's just friction. So this is what I would consider a one-to-one setup, where the input and the output, these two gears here, are the same diameter. And it makes no difference if they are both 20 tooth, if they are both 40, if they're both 60, whatever they are, as long as they are the same, it produces a predictable outcome of I would call characterization. Can't find my down here. Mounting a piece of PVC in here and a line. I don't know if here's the vertical line that runs up here. Mount it on here, and when you start the cutter, or start in this case a marker at the 0 point, as you move on down, this piece rotates, and at 7.75 inches, it crosses over. That's going to vary for everybody. It all depends on the diameter of the hub of the chuck. If you're using a stronghold, they're all going to have the same 2-point-something inch diameter, so they all produce this repeat right here out of 1-to-1. And if you measure that length and you know it's rotating 360 degrees, you just divide 360 by 7 3/4, and it's going to show you you're getting about 50 degrees of rotation per inch of travel. And if you can zoom on the whiteboard here, what I was trying to show here was like from the end view, if we have this much travel or rotation per inch of travel, if you try to predict what the resulting spiral angle will be, and depend on the diameter of the stock. 1 inch this way, and that height right there is going to vary with your diameter, or more precisely, the radius of the peaks. And I've been cautioned before about not getting too bogged down in math on these jig presentations. So I'll let it go at that. This fearsome looking thing here, I just stave jointed up some oak into this cone, and it's to show the effect of radius on the helix angle. If you were to bring it down to 0, the theoretical point out here, it would have no helix at all. It would just be parallel to longitudinal axis. But it grows as the radius grows. And down in here, so I was turning a 2-inch diameter object, like a candlestick or something. Using this setup right here, it would make a 35-degree helix angle. If I was turning something like this pineapple I'm going to do tonight, we're up here around the 4.5 inch mark, so it's somewhere around 56 degrees. You can maybe see this. You see the angle that the marker was just ran from right to left or left to right, while this rotated. Nothing else moved except for the linear travel of this. And so it produces a helix that is changing based on radius of the piece that it's cutting. The settings achievable with just using the 20, 40, 60 sprockets. These are 5 of them. They range from almost no twist at all to regular barbershop pole of a very tight helix. And you would want to use something that's this tight or even tighter if you're doing a bowl. Like I made this bowl here over the weekend, and it's midway through hand working it with file and such. But to make these slots, I had to make a homemade disc that I made from, it's I think the equivalent of about 120 tooth sprocket, but it's just sandpaper wrapped around 1/4-inch plywood with formica faces to form flanges, keep the belt on. Okay, so here is said pineapple. Because this one is a spindle mounted, I made this little adapter thing here. It helps if you clamp something. Okay, so you can kind of see what's going to happen. We can get a better visualization of what's going to happen. This is actually a mount that I made for using a Fordham tool, the handpiece of a Fordham tool. And I just put a 1-inch dowel in there with a mechanical pencil, so we can, before we commit to cutting, you can see what your results are going to be by drawing a pencil line on it.
Barry, what's a Fordham tool?
I'm sorry?
What's a Fordham tool?
Oh,
Like shaft Dremel.
Okay,
it's a motor about that big around, and
gotcha.
it's got a flexible shaft.
A little more than I thought. Good for hunting office though.
The pencil lead wants to dig in, but so can the camera? Yeah, I can. The overhead camera can see that.
Yeah, we saw it pretty good. In
So if I did that on the forward direction, missed the belt. You see, you can kind of see how they cross over here. And given our choices, this is probably the best set of gears to use for the pineapple. The next one would make maybe a too steep of a helix or too shallow of a helix. So, and in the interest of getting this done, go with that one. And I was going to use my Fordham tool tonight, but the reverse went out on a long time ago, and 2 days ago, forward went out on it. So it needs to be repaired. So I'm gonna use this noisy trim router. Oh,
I have a question.
You got a question?
How do you control the depth of cut on your cutter?
okay, thank you.
You're welcome.
Quite often, if it's like a hollow vessel and we're just piercing, obviously you don't need a depth control. Like in the case of the bowl, you just go right through. Well, you actually don't go right through. You do it piecemeal. There's just too much burden on the cutter to go through in that case, that bowl, it was a 3/8 thick wall. Just too much loading. But I'll show you on this thing, on this version here for the Fordham tool. This is an Allen key. John Kelsey's idea. I had a piece of metal rod that was in there. And when he first saw it, he said, "Oh, you use an Allen key." No, but I can. Anyhow, it's with a little set screw up here. It's adjustable.
Gotcha.
And trial and error, you figure out how far inside of your tool you want to go for your depth of penetration. And it is trial and error on your first couple of cuts. So obviously you start out intentionally shallow. You can correct shallow, you can't correct too deep. Unless you decide to paint the object and you can fill it in with putty and recut it. They don't have to be lined up with any kind of device, just visually is fine. And this is just simple, like old time lathes would, metal lathe would have, where you got a right angle corner here. And you make similar cuts in your wood here, so you can tighten it up and restrict both lateral motion and up and down motion at the same time when you tighten it. This, I can feel there's a little bit of chatter in this. When I have it for at home, I have it with HDP, this high density polyethylene tape that you can buy. It's like 1/16 of an inch thick, and it glides on the metal very, very slickly. This is just wood on metal, so it's kind of hope for the best on chatter. Is this out the buck live?
I don't know. You might have to push a button on it. No, on the outlet itself, on the. I think it's live, but if it isn't, there's a board in there. Yeah.
Okay, yeah. I don't know how you want to compensate for the noise level of this.
Put it on to see if it works, sure.
I'm going to compensate myself because I'm right here.
We should turn on original. Yes. I'll let it
since I'm not wearing my hearing aids and I am wearing hearing protection, if a question occurs while I'm doing this, you can flag me down or something.
And for the Zoomists, we're gonna do this using original sound, so you're gonna hear the noise of the router.
What's that?
The people on Zoom are gonna hear the router. We're not filtering it out.
Into all this.
Okay, so to get it, you get uniform spacing and at the angles that you want, at the spacing angles that you want, you have to have a common stop point. This thing has to, whether you put on these little clamps that you clamp down here at the left and right end that you travel in between it. If I was just putting grooves like say from here to here, I'd move it to where I wanted it and put a clamp on there. These clamps I never adjusted for the wider bed. These fit on my jet. So we're not going to use stops here, but we are going all the way end to end. I'm going to use for my park position up tight against the tailstock. And Angelo, to finish up on your question about depth control, for this thing, I made this PVC piece here that by loosening this hose clamp, I can slide it. I have maybe 3/4 of an inch range of travel. Right now I have it about, well, the zoom camera can maybe see, so it's about an 1/8 of an inch protrusion. Okay, so I picked one of the indicators where I had marked it, and we're going to do every 30 degrees. So there'll be 12 grooves on here. So they'll be about an inch apart at the biggest diameter. And as long as they don't collapse into each other at the small end, you're going to have grooves that all come together, and you still got some more to cut, and it's all been grooved, you have no more surface to work with. So we're going to just use that as the stop. So with it pinned there, I'll lock the belt. And a big mistake I make real often is I forget to unpin it. And you start to move and nothing's happening here. And the belt is just stripping on the teeth. Noise time. I failed to tighten everything. It is not tolerant of this rotating because the nose of the cutter is not directly over the center of the belt at all times. And so when you pivot, it's like you're either getting ahead or behind of the curve, and it produces defects like I just did right there. We bring it back to the park position. We unlock the belt. And we advance it 30 degrees. And then lock the belt again. And it's that drill over and over again. Don't talk about happy dinner that I haven't really been. Okay, as I said at the beginning, something always goes wrong with these. In this case, I'm not getting this down tight enough. And so the side force of going across the
I was gonna
wood.
say, it looked like your cutter twisted.
it's torquing this. If you look at it now, it's on about a 10-degree angle with regard to where it should be. And so it's producing an irregular pattern. I should probably do a shallower depth of cut to reduce that side force on it. Yeah, it's gonna have a whole different set now if I continue with that because it shifted and now I've adjusted it back to where it should be. What I'm gonna go ahead and do is cut some of the reverse angles on here so you can see the operation forward and backward. Right off the back end. My hearing aids have to power up. Okay. Since I've screwed the piece up pretty irredeemably, I'm not gonna take up all the time, but had I had this fixed so it couldn't rotate better, there's a lot of ifs. If it didn't shatter on this bed, I guess you have to trust me that it works better at my house on the lathe it was meant for. But also, if I'm doing something, felt like I'm in a hurry up here and I didn't take the necessary precautions of, quite often you see a guy demonstrating on the lathe and at the last second, just before putting the tool to it, he realizes he hasn't locked down here. When you got like 5 things you have to lock and 2 things you have to unlock in the right sequence, it just complicates things. But anyhow, that's the spiral turning jig. Angela.
Yes, be that as it may, the skill and tenacity at which you went after all of these parts.
I'm sorry.
Is amazing to me. Because I don't have the patience or the skill to make the parts that go together. So kudos to you.
Is this your own design?
Yeah.
You on a moonshot for NASA?
What's that?
Were you with the NASA moonshot? Seems like a lot to put together, the angles and.
Well, I am retired from NASA, but I had nothing to do with the space program.
Okay, well, that makes complete sense now, I
If it
understand.
flies in the air, I had something to do with it, maybe. If
Okay,
it flies in space, I don't,
okay.
except for the shovel, because it does both.
Barry, I noticed that your cutter is not always 90 degrees to the surface. Is that just something you gotta live with?
Because I can't, to change the cutter while you're in
That would
motion,
just be too much.
you can't do that. You have to basically figure, well, okay, I'll do this. Like say I was turning on a sphere. I would maybe set it at 60 degrees. So you couldn't notice the difference in depth on the first little bit. And only take it over like to what on a globe would be like the tropical zone.
Right.
And then you have to for the first cut, pick up that same groove where you left off,
Right.
and tighten your belt there, and then you can go about doing the next segment. And it would be probably, 2 hours of doing it versus continuous.
Right.
On
But
In
this is
general-
repeatable enough. You can do multiple passes if you gotta make some area deeper than others, right?
yeah, that's why I prefer piercing work, where
Right.
you can kind of piecemeal it back and forth.
Right.
You would have solved, you wouldn't have had any of those problems if you'd made a shallow cut and then followed with a deeper cut. I mean, you wouldn't have had the sideways torque on the rotor.
Right, but I'll admit that this particular final piece here has always been a challenge, no matter how much I tighten it down. Excuse me, I think I'm gonna put
You need some way to
some sandpaper
or something.
on
in there.
double stick tape in there so that it locks down better.
Or a
Yeah.
And the
pit.
same with down here, because it is, whether I'm making something at home and I just lost all my time turning the object, and now I do it actually on this bowl here. It was an earlier before I went to a bigger diameter pin. The pin got loose enough that it vibrated in and engaged this. One of those kind of things that only the maker would notice it, but
Well, I saw it right off. I
Oh,
didn't
did you?
say anything.
okay, well, anyhow,
You can hide it with the light.
there is a
That's where the light goes.
sticker on the inside,
Oh, yeah.
a little half round.
Yeah.
Little sandpaper.
Yeah, I was going along, all of a sudden that thing vibrated in. And so I was still traveling, but I was traveling on the axis and it wasn't
Right.
advancing anymore. And it was only because it began to then chatter more than it normally does. But the process on this was I used a router bit, there's a company, all they make is router bits, Whiteside. And they make a 3-flute upcut router bit. This was a 1/4-inch 3-flute upcut that I pierced with. And then I used the kind of cutters that Dave Shell was talking about a couple of months ago, They come in various grits. They're Cutsall makes a line of them, and
They're a bird.
Saber company. They're identical as far as I can tell. They're what you call structured carbide, I think. And they come in the case of some cutters, 4 different grits. In the case of others, 3 grits. I got about 12 of those, and they aren't inexpensive, but they do a great job. But because the carbide pieces are so long, if you got, like, say, a 5/16 series where it's just a shaft with structured carbide on, the fine one is just barely over 5/16. And they're all based on the same base metal, and so as they grow the structured carbide taller, you wind up with, that's like more than 3/8 of an inch. You did it cleanly. Just once you had the hole all the way through, you just went ahead and penetrated with that saber tooth and just advanced it right along there. So anyhow, I want to conclude by saying what I'm working on right now. I do more jig making than turning. So despite today's display, I do make a pretty good jig. I do a pretty mediocre job of turning. But what I'm working on right now is one for, because a big use of spirals is bowls and platters. And a limitation that you have here, no matter how you position this over at some acute angle, like for this bowl, I had it rotated to the average slope, like the slope of here versus the slope over in here. I picked about a midway point and set the router or the cutter perpendicular to that point. So it was cutting a little on the one side over here and the other side over here that was not perpendicular to the work. And the problem is when you get to where this gets steeper and steeper, especially as it grows in diameter, a small motion of this produces a really long length, like I'm trying to indicate here. The further out of the radius you are, the heat. Right there, when things go wrong.
Like a wardrobe malfunction.
Yeah. Yeah. Anyhow, it gets so steep that a 1/4 inch of motion and you're cutting 1.5 inches of slot. And so what I really have to make is one that I don't have to make it, but I desire to make it, is one that changes the orientation 90 degrees. And it's a platform that your router would be, or your cutter, whatever you're using, would be kind of oriented axially. And as you move it left to right on this T-slot aluminum stuff you buy, T-tracking for making tools, on T-track, as you slide it left to right, you're still doing belts and pulleys, and all these parts are the same. And in fact, this part right here wouldn't change at all. Just that instead of this kind of carriage, it would be one that you fix in place and it slides left to right, and your router plunging takes you in this way, or at whatever angle you set it at.
You also do it so instead of a sliding carriage, it's a pivoting carriage. You might need a tent.
This was
tensioner.
One of you guys at Keystone brought that up when I was demonstrating down there. And this product that is made by the Flute Master makes this bead chain thing I was talking about. And theirs is based on that. And what they do is and it's all these blue plastic parts that I'm not sure if you have to buy a dedicated router. And this is a Bauer or whatever, a Harbor Freight $34 router. But you buy this router that exactly fits into this cone and has an adjustable depth knob on the front, a threaded knob. I don't know if they're special cutters or not, but it has this bead chain. And the post for the bead chain is vertically below the tip of the cutter. And it's like a post that sticks up, and you hook an eye on the one end of the bead chain on that post. And you wrap it around a mechanism, and you have 3 different helices, ratios that you can set. You know, there's 3 different diameter pulleys with the molding of bead chain female impressions on it. And you droop the bead chain in there, and both ends of it hook on to this post, and it has a pretty high tension spring in that bead chain to keep it under tension so it doesn't slip in the slots, but loose enough that it can tolerate. See, right now, if I try and move this in or out, I am tensioning the belt, and I'm liable to break the joint I put in or break any belt because it's not meant to go like that. But if I put a spring in it, trust me, I've tried. I tried 3 different stiffnesses of springs, and none of them were stiff enough. It's just a shortcoming of the tooth. While it's very nice, it's not meant for a high load. It's meant for easy moving. But that post is directly above the nose of the tool, and so as you move the tool in or out or rotate it, that post being directly under the nose is always right at the center of action. So as you come in, and then if I were cutting a sphere, I just go ahead and bring it in from over here. But again, I'd have to hold it down with my hand because they don't rely on any kind of stable carriage. They show you how to make a plywood right angle thing, like a 3-inch wide board that goes out and goes up, and a stiffener block in it, and you mount the router in there. And to me, it has a lot of it's a lack of stiffness. You know, it has a lot of flexibility this way, which would give me concerns. But if you look at YouTube and look at Flute Master, you can see about a 14-minute video of them doing it, and they're doing it on a piece not unlike this. And I saw how the guy was rotating it, and I was thinking, that's what I have to incorporate into mine. But I just, I wasn't able to do it using these materials. If I'd resort to a bead chain, or like that router crafter from 50 years ago, like a garage door opener, in that it had a cable that wrapped about 3 revolutions around the pulley, and that's where the friction came from. The slightest amount of tension, and that thing wasn't slipping. I've tried wrapping this on here, and just the flat belt nature, it wants to jump over itself. So I've tried a lot of avenues, and I cannot overcome the one of I wish I could, that you could just go ahead and move this thing perpendicular to the surface. It'd be great. Get a uniform depth. I'm not able to do it, and it's hard for me to admit that.
Yeah.